Welcome to springlib.
So in this problem, we know that you clean dishes 70% faster than your roommates. So I'm just going to assign random numbers to these, or not really random, they're kind of thought out. So for the roommates, I'm just going to say that they can, in 1 hour, so our quote unquote labor equals 1 hour. And in 1 hour, your roommate can do 10 dishes and can vacuum 10 square feet, which is not a lot at all, but let's just suppose. And now you can clean dishes 70% faster than your roommate. So 70% of 10 would be 7. So 10 plus 7 would be 17. Another way of calculating that would be by using the following formula. It would be the observed minus the expected over the expected. In this situation, the expected are both 10. And you know this equals 0.7. What this represents is the percent difference. So yeah, you can do, and then your observation would be whatever this comes out to be, and we get 17 when we do that. So that's just the example formula I used. If you guys are doing this on a test, I'm pretty sure that'll work too. So I have 17, and now I know that I vacuum 10% faster than my roommate. So 10% of 10 is 1. So I know that I can do 11 square feet in 1 hour. Again, not a lot, but just imagine. So now we have to figure, so what we have here is basically a comparative advantage matrix kind of thing, right? We have to figure out who has what. Now it's pretty obvious to see that in both situations, dishes and vacuuming, I have the absolute advantage. So here's where the problem can come up. I can do everything more quickly, but I only have so much time. So we can come up with a trade situation if there's a comparative advantage involved. So to figure out the comparative advantage, we have to figure out the trade ratio or the opportunity cost of each thing. So for you, one dish is equal to 11 over 17 square feet, right? And we get this because we have 17 dishes equals 1 hour. 1 hour. And we have that 11 square feet equals 1 hour. And because they both equal 1 hour, we can set them equal to each other. 17 dishes equals 11 square feet. And when we divide to just get one dish, we have to divide by both sides by 17. So 18 equals 11 square feet over 17. So one dish is equal to this. Oops. Oh no, this is not working out. Okay. So we have that this is the comparative advantage or the opportunity cost for one dish. And oh my gosh, we have to do the same thing for square feet, right? So 1 square foot is equal to 17 over 11 dishes. And now for the roommate, we have to do the same thing, right? So we have to figure out how much one dish is equal to, and one dish is equal to 1 square foot. We're going to use that same formula where we set them both equal to 1 hour, and then we can set dishes and vacuuming equal to each other, and then divide by the coefficient of whatever we're looking at. And now 1 square foot is equal to one dish. So we have this. Now we just have to compare the opportunity cost. So I'm just going to write this out on another page. So in this matrix, I'm going to write you, roommate. This is going to be opportunity cost for dishes. This is going to be the opportunity cost for vacuuming. So for you, the opportunity cost, one dish is equal to 11 over 17 square feet. And for your roommate, one dish is equal to 1 square foot. Now for vacuuming, 1 square foot is equal to 17 over 11 dishes. And here, here 1 square foot is equal to 1 dish again. So one dish. Now what we have to do is find out where there is the lowest opportunity cost, right? So 11 over 17 is less than 1. So you have the comparative advantage when it comes to washing dishes. And 1 is less than 17 over 11. So your roommate has a comparative advantage when vacuuming. So here's what the problems that may arise. Your roommate might be like, wait, you're faster at doing both. Why don't you just do them? We can both save time. But the problem is you both only have 1 hour in total. So by you doing the dishes, you're saving time and being more productive. And by your roommate vacuuming, he or she would be saving time and being more efficient. You can, or you both together can be more efficient this way. Now, when this comes to like a trade analogy to this problem, we can see that there is an absolute advantage in one quote unquote country, and then no absolute advantage down here. So what could happen is one country tries to trade more than it needs to. It basically becomes dependent when it shouldn't need to. There should be a equal trade-off so that things become more efficient. So that's a little example. Put your own situation. There's a lot of examples in the news if you want to look that up, but that's just like a quick little ditty here.